So we are going to simulate a skateboarder on different planets. So you can see the tab on my right hand side. So we have Earth right now. So the acceleration due to gravity on Earth is given here. That is 9.8 meter per second square. We can change it to Moon, Jupiter, and some custom. So basically, when I say that I am changing the planets, this primarily means that I am changing the acceleration due to gravity. So you can see on Jupiter, the acceleration due to gravity is 24.8 meter per second square. Similarly, uh, on top you can see the energy graph. So energy graph varies with position as well as time. So it will be very interesting to see how different energies they behave with respect to space and time. So let's choose the moon first, and to keep it simple for the first simulation we will take a parabolic path. I am putting this lady on the start of our simulation. Now you can see uh, the graph moves. I will just maximize it. So with position you can see that the total energy remains constant at around 260, and the potential energy, which is blue line, it first reduces, then it goes to the initial position. So this is because the friction here I've put friction to 0, so there is no energy loss as such. So you can see the thermal line of red, the, the red graph. The red graph is always at 0 because there is no energy dissipation. The kinetic energy starts from 0, it goes to maximum on this point, and then again it goes to 0. Now let us see how the energies they change with time. So I am putting this time uh, tab. Okay. So now you can see with time you will see different. You'll see a sine curve kind of a graph. Again, the total energy will remain constant. The thermal energy is 0, and kinetic and potential energies are basically uh, the opposing sine wave functions or sine cos wave functions. You can see with time how beautifully the graph is moving. Now let me just change our planet to some different planet. Let's see what happens on Earth. On Earth, definitely, since gravity is going 9.8 meter per second square, which is almost like 6 to 7 times of that moon, this graph is going to shift up. So when I start the simulation, you can see it has shifted up. The reason is the total energy has gone up, and it's a step response kind of the graph. The sine wave and the cos wave, they just increase in the amplitude. The rest will remain same. Now let me just uh, change it to Jupiter. Now Jupiter, the gravity is more than 9.8, so there will be again a step response, which you will see. So now you can see that the response is changed. Accelerating at the rate of 24.8 meter per second square, but then the skateboarder is also decelerating at the same space. That's the reason the skateboarder is not going off the track. Now as soon as I give some friction here, you will see it will start. The curve is lessening with respect to the amplitude, and eventually it will go to 0. So friends, that's how it works. If the gravity works in an amazing way when we go on different planets, and that's how the comparison is. You can see that when we change planets, the the frequency of the skateboarder, if I put friction to 0, it increases because the pace is fast, and that that's how it is. Yeah, thank you.